Okay, so just following from what Sharon has spoken of, I'm going to be more focused on the actual inwards development. So this is the water resource decision support system. So this is the added value component to FBIS. So as we saw now previously, being able to show those species which are endangered or endemic. I mean, if it wasn't for FBIS, we would have never been able to show that in the past. I mean, many a time during the Reslim O project, which was also quite a big project we had, we constantly tried to find data and pull it together. And yeah, so FBIS, you know, really has been kind of a big plus, instrumental to our area. Exactly. And I mean, as Sharon also said, inwards had originally been developed and piloted in the Olifants River catchment, but it's only now that we've actually been able to incorporate the biodiversity data into inwards. So I'm just going to be chatting a little bit about how that has gone so far. And we are roughly a year and a half into our project. So if we look back at the objectives, you'll see the second objective was developing the support system, and that obviously it also must integrate or at least communicate with FBIS to be able to draw in the freshwater biodiversity data alongside with the drivers of change data. What I mean by drivers of change is more the non-biological types of data. This would include water quality data, your hydrological data, which often have limits that are specified, which we refer to as resource quality objectives. Sharon mentioned it earlier, the reserve. And these are actually specified to conserve biodiversity, yet they are never brought together with biodiversity data. So you might be compliant with your hydrology, but no one's actually really looking at if it's making a difference with the biodiversity. And hopefully with FBIS and inwards working together, we can start to catalyze this change in the way in which the water resource managers approach compliance, where the compliance actually now also integrates the biodiversity data component to it. Yeah, so I've already mentioned that. So basically we're trying to enhance the systemic and analytical capacity of FBIS by bringing in the drivers of change. And this is only possible by working with a number of stakeholders. And I mean, it's quite great to actually see Mike on the call, Mike Silberbauer, like from Department of Water Affairs. I think if it wasn't for Mike being in the Department of Water Affairs, we would never have access to water quality data. And I think he's either retired already or is about to retire, and which is a little bit nerve-wracking, and hopefully the water quality data will continue to be available. But yeah, great to see you on the call, in the meeting or the call. I don't know what really to refer to it as, the workshop today, Mike. But yeah, so we're trying to pull in data from various sources, and obviously this means that you're working with a lot of partners, and this is not just the biodiversity data, but also the drivers of change. This could be water quality data or quantity data, and I'll show you some examples. So the environmental drivers of change that we're referring to, but mostly focusing on is the hydrology and the physiochemical, so the quantity. So the geomorphology and sedimentation is actually, as far as I know, dealt with in FBIS. Helen, I don't know if you want to jump in there and say, but I do know you guys do take that into account in your decision support systems, and in which case we would redirect the user to FBIS and vice versa.
Yeah, we just included in terms of geomorphological zones, but not specifically in terms of drivers. But we do, you know, make note of whether it's a mountain stream or a lowland river. That's more or less the extent of it.
Okay, great. Okay, so yeah, so the output would obviously be the decision support system, and obviously it would need to integrate the biodiversity data. So where are we at the moment? So version 1 has been released to the stakeholders and is available on the website, and I'll share the link later on. And we've also now finished off the API development, and this is thanks to Tim and Dimas from Cartosa, who've actually been instrumental to us in terms of being able to link the biodiversity data, but also helping us in the initial phases of inwards with a very new technology that I didn't have any experience in, and Dimas was really on top of it and helped us out significantly. So thanks to that. And we're currently working on version 2, and we're hoping to release it in, I think next month, yeah, May, the end of May. And I'll show you some of the bits of it that we've currently developed. And yep, so that's essentially where we are at. And then ultimately, we're hoping to get to this fully integrated system where you're looking at water quality and biodiversity, looking at hydrology and biodiversity, but you're also looking at water quality and hydrology together. So really a decision support system where you can look at the different types of compliance and targets that these water resource managers need to meet. So the way in which we designed inwards is a little bit different. So far as, correct me if I'm mistaken, but most of the systems that we've seen are web apps. So, hosted and the interfaces from a website, and that's how you interact with the databases or submit data. We went a little bit of a different route because we're working with very, very large data sets. So roughly inwards grows by 25,000 records a day. And, we've got 76 data tables and views and about 14.8 million records currently. And this is purely because there are many hydrological monitoring sites right across the catchment. And all of these hydrological sites, well, most of them have real-time systems, and they capture data every 15 minutes, send every 6 hours to the DWS servers and the IUCMA servers. So what we've done is essentially replicated what DWS has, and the only reason why we did it was that their servers tend to be slow and unreliable at times. And we can't risk having the decision support system not being able to draw, for example, historical data for long periods of time. So we rather went the route of replicating a lot of the data tables that they've got, collecting all the data on a regular basis. We've got cron jobs that essentially trigger every 6 hours, pulling the data as soon as the servers get the data. And this is just discharge data and water quality data. We've then got various scripts that run on the server, and this is to process the data. We need to have a look at compliance so that if we need to send warnings out, so the data will go through a screening script, and then obviously also needs to be processed to be stored into our database. So there are a whole bunch of different scripts that run on the actual server itself, and this is a server hosted in the cloud. The server is tiny, only costs us, I think, about $10 a month. And the reason why is we don't need a heavy duty server because all the processing for the actual inwards program happens on the client side. So we decided to go with a program, well, what's it called, architectural framework called Electron. So Electron is essentially a desktop-based application, but can be developed for cross-platform. You only code it once, and you can then build it, and it'll build for Windows, Linux, as well as Mac. And it is constructed using CSS, HTML, JS. In our case, we used Vui. So a lot of the components actually can be transferred back to a web-based application if you want to. So it is very kind of flexible and dynamic, and that's why I went with it. And especially since in South Africa, a lot of your organizations don't have reliable internet. And also, as I said, the hydrological databases are large. So if a user is constantly having to pull hydrological data from the server, it will put strain on the server as well as then obviously their internet connection. So we rather went the route of that the program will be installed. Okay, so this part hasn't actually been implemented yet, but some of the local databases have been implemented. But essentially, when you install the application, it creates a local database, and then anything that you draw or chart can be stored locally, meaning that you don't have to draw it again. What we will in the future also offer is that you can download the entire database onto your system, which currently sits at about 1 gig, if I'm not mistaken. And then you will be pulling the resources locally and not from the server. So it's basically a way of minimizing the server costs. So we wouldn't need to ever scale. We can keep it at $10 a month, and the user would be, the computer that the user is using would be doing all the heavy lifting for us. So it's a good way to be able to save on resources and then also obviously ensure sustainability, because obviously, when it comes to server costs on a monthly basis, it's very difficult to ever get anyone to commit to very expensive server costs. Okay, and then also because Chromium, I mean, because Electron is a Chromium engine, you can develop the user interface using a lot of the open source kind of projects that are available for web development. And there's a big community of support. As I said, it's also got an offline functionality, which is great. And then you get access to local storage as well as processing. So for example, if I've got an i7 computer with loads of RAM, when I run an analysis on, let's say, indicators of hydrological alteration for a site, you know, if I had to run it on the server would probably take a good hour. Actually, I'll show you, because currently those scripts are running on the server, so you'll see how long it takes. Yeah, so all in all, we went with this route, and I thought, well, we thought that it is definitely a way of hooking the local stakeholders and not having to pay huge server costs in the future if they need to take it over. Okay, so the question is, how do you use bioinformatics in conservation, and more specifically into action? So if you are just drawing drivers of change data, be it hydrology or water quality, the analyses are absolutely useless if they haven't got some form of benchmark that you need to meet, and those benchmarks need some form of action associated with them. So what we keep reiterating is, and we'll show you an example of a chart that has actions and people linked to it. And I think it's just important just to keep reiterating that if we are going to get to the point where inwards is used in conservation, it has to incorporate action within all the different data representations. Okay, so just a quick little overview, but I'll also give you a little tour of inwards if everything plays ball. Okay, so you met with the login screen. Now, basically the login screen is there. We didn't want it just to be open to everyone. We do want a process of registration just so that we can identify if you are from research or if you from the water resource management perspective. But also we've got a data table on the server that allows you to store custom preferences and different types of analyses so that you don't need to redo them. So you basically create a user profile. Okay, the first is the unverified dashboard. What unverified means is real time. So no one's actually in the field looking at the river and saying it's 5 QMX. It's a little probe. It sits in the river, takes a sample every 15 minutes, sends the data every 6 hours, unless a threshold is surpassed or goes below a threshold, then it'll send a warning instantly. But that's what we mean. It's real-time data. And the dashboard, you select your sites. You can select single site or multiple sites. It then charts it. And the key things are these bands. So that shows you where you are in the hydrological, historical hydrological statistics. So if you're in the 25th, 50th, so it just allows you to see how you're performing this season. And then I just want to point out again, this is data coming from the Department of Water Affairs. More recently, we've been given access to the IUCMA database, and that's been, through sharing agreements. And now we've got an API that accesses their data as well, and we'll draw into the inwards in the next version. But yeah, sorry. So you've got all the stations. They're represented on the maps. You can either select on the map or from the stations list and search. Set your date ranges. You can choose if you want time series, box plots, or flow duration curves. And then obviously if images do exist for the site, you can also have a look at the different images. So I'm not going to go into a huge amount of detail because I've just mentioned. So for example, there's the 50th percentile range over there. So we've got statistics that are calculated, stored in the database so that it doesn't have to be recalculated each time. So this is where we start drawing from a real-time database as well as from the verified database. And the verified is a time series that consists of data that is on a daily time step. And then obviously these real-time data, the real-time data is on a 15-minute kind of time step. Okay, Tpc dashboard. Okay, so by Tpc, we mean threshold of potential concern. So these are not specifically a benchmark that's been set, but these were originally formulated by Kruger National Park, I think back in the 1990s or 1980s. Oh, 2000s, early 2000s. And essentially it was a way of preempting almost a threshold breach or below. So, but assigning actions before you get there. And at each level, which I'll break down later on, there would be someone that would be responsible for an action, or multiple people for an action. So this was a request from the Kruger National Park. So as you can see, they've got 6 sites. So it's all the major rivers, the Lavuvu, Letaba, Limpopo, Crocodile, Nkomati, Sabi, all of which flow through the Kruger National Park. And they've got benchmarks that have been set and gazetted by the South African Department of Water Affairs and need to be met. So Kruger National Park also has a responsibility as a watchdog to ensure that that these levels that have been specified, called the resource quality objectives, as well as the reserve, are met. But what they found is it's too late to respond when the flow gets to the reserve. So you set various targets before. And essentially, the dashboard allows the Kruger National Park Water Resource Manager, in this case it's Eddie Rydell, to quickly get an overview of the current status as well as where they are within the different threshold bands. So for example, that's an inform. So essentially you would get someone like Jacques, who's the river technician, would be following this chart, and he would inform Eddie, who's the water resource manager, that the discharge has now gone below the threshold. Then obviously low worry, they would be contacting the Department of Water Affairs, and then obviously you've got your reserve. But in times of drought, they've got these little bands, the 70th to 90th, where they try and operate. So it's almost acknowledging that the flow isn't going to be static, so we can't really operate according to a line. We need a band for the flow to bounce back and up. So it's almost like a target band. Yeah, so then observed as well as the last year data, and then extreme worry, we're on the phone and we're phoning the minister, that kind of thing. So there are various actions associated with it. And these are logged in what's called the River Management Communication Log Sheet. So for example, I mentioned Eddie. There's Tendai, he's another water resource manager, and he's from the IUCMA. But the problem would be, okay, there's a river flow that's only 0.43. This is the action that they took, or the options that are available to them. So inform DWS, and then ultimately the result, okay, flow stayed around 0.4, but at least it didn't go further down. But the entire, what would you call it, event that happened with the chart. So we're talking about a line on a graph resulting in an actual qualitative process of communication, responsibilities, and action. So the chart is ultimately used as a guide. Yeah. So this is the water quality dashboard. And once again, as I said, if it wasn't for Mike, I don't think it would be possible. But yeah, so really, once again, very similar structure on all of the different dashboards. We haven't had a massive focus on the user interface as we're first trying to get all the functionality in, and then we'll start playing around with the user interface at a later stage, obviously being guided by the stakeholders as well. But once again, you can choose the sampling type, the variable that you would like to analyze, and then you can either select from a map or from the station's tree. And then we've got a load duration curve. So the load duration curve integrates water quality as well as quantity. So it's your concentration multiplied by your flow, which allows you to calculate the amount of tons of the pollutant that's, or water quality constituent that's moving through the river. And this is instrumental, especially when it comes to assigning licenses, and I'll show you next. We've also got a duration curve. A duration curve is quite a nice way of representing an entire data record for a single site in a single chart. We've then also got our box plots, which allow us to kind of have a look at it seasonally for every single month across the year. Especially in South Africa, in these river systems where you go through a wet period and a dry period. So obviously, as you go through your drier periods, your concentrations increase as your discharge decreases because there's less dilution capacity in the system. So why do we integrate hydrology and water quality? if you are wanting to assign concentrations for discharge into the system, in the perfect world, this is how it would be done. And currently, we've actually got a great case study with the IUCMA, who's actually, for the first time, asking a mine, and it's a anthracite mine, so that's the same as coal pretty much, but it's the leftover bits of coal, to look at the assimilative capacity of the river system and assign their license concentrations according to the assimilative capacity of the river. And
To conserve biodiversity.
yeah, to conserve biodiversity, essentially, yeah, so that you don't compromise the resource quality objective. Sorry, so you'll see here, you've got a resource quality objective, and it says we need to keep it below 50 milligrams per liter as an example. But now you've got your discharge coming in, which is only 0.3 QMX, but the concentration might be high, meaning the load is also high. And if it meets the river system, does it actually have the volume, that is the receiving river, does it have the capacity to actually dilute it to a safe concentration to ensure we meet the resource quality objective and to ensure macroinvertebrates and fish aren't compromised? And really, that's why we integrate load into the decision support system. Yeah, so now this is more just like a table view of it, but I mean, you've got your sulfate concentrations, which are measured by the Department of Water Affairs for a specific day, but you've also got your discharge data if a WEA exists at a site. And essentially that allows us to calculate the load. But what's key to point out here is traditionally, with most disciplines, it's always been hydrologists and ecologists or water quality specialists, and they've never really worked together. So what Inwards tries to do is pull in both the hydrology, the water quality, and then the biodiversity data coming in from FBIS, and hopefully you can draw all these multiple disciplines into one system working together. Okay. I won't go into detail about the load duration curve, but it's just basically to show you under which hydrological conditions your loads either were compliant or non-compliant. Okay, so collaboratively developing inwards. We work in a way in which acknowledges that if you don't collaboratively design and develop the system together with your stakeholders, you're going to get almost like a push, not really a pushback, but you might actually find that you don't get the stakeholders adopting it because there's no sense of ownership. So the route that we take is to try and get the stakeholders to drive the process. And we do this through various ways, either on an ad hoc with a phone call, they have an idea, we'll record the idea, or we can do it more formally like this, where we give them different options of types of analyses that they might want to see in the system. So this is, for example, the hydrological conditions of alteration, indicators of hydrological alteration, sorry, and different kind of flow indicators and statistics. And, they're asked to select, but that's also applicable when it comes to water quality as it does hydrology. And I'll show you some interesting responses now. So we give it to them in form of a pretty kind of structured sheet of tick boxes, but also space for comments or any additions that they can suggest. But you'll notice here, so Tendai, who's the water resource manager who focuses primarily on hydrology and the management of dams within the system, only really ticks the hydrological components. The water quality components aren't ticked at all. You then get someone like Eddie Rydell, who's a water resource manager, but across the spectrum of both water quality and hydrology, who will then go and tick all the boxes. So it's quite interesting how a group of diverse stakeholders actually start building the picture together because each one of them have different specialities or different needs. And that's kind of the approach we've taken. So taking into account what they need and then trying to implement. And what does that kind of look like? Well, this is the IUCMA dashboard. So very different to the TPC dashboard that you saw. They communicate with their stakeholders with green and red. So almost like a robot for the environmental flows. So essentially where you see red means that they weren't compliant, but with obviously the 60th percentile, which is quite a strict flow rule. And under the drought conditions at that time, it would have been the 99th. Yeah, so that's all their sites that they were concerned with, and that's all their sites that they're responsible for to ensure compliance. Then we've got someone like Robin Peterson, who's both he's a river ecologist, so he looks both at the hydrology and water quality, as well as then obviously the biodiversity. And this is where FBIS comes in. And I mean, we would never be able to do this if it wasn't for FBIS. So FBIS allows us to pull in all the different sample sites. So this is for the Limpopo. So you can select different water management areas. I've had a bit of a freeze in my brain there. Different water management areas, and all the blue little dots over there are hydrological monitoring sites, so river flow sites, and all the green are the biodiversity sites or fish sites, not the macroinvertebrates, but the fish. And that comes from FBIS. And then essentially it allows the user then to select which fish site they want to look at, as well as which hydrological site. And then we've got an overview tab over here, and it's not complete, so that's why I said it hasn't been released, but essentially there'll be a button here which will allow the user to go to FBIS, because we don't want to bring in the kind of detail and information that FBIS has already gone and done. So over here, we mainly focus on hydrology. We'll give a broad overview of the species that were found, and we'll look at the different types of hydrological representation. So just basically, for example, a basic time series of the different fish and when they were caught on that sampling day, but then also a in-depth kind of hydrological analysis. So this is the verified hydrology, looking at all the different indicators that you saw the participants tick. So we can look at low flow indicators, we can look at, you know, days of zero flow, we can look at timing of events, and I'll show this to you in the live preview. And I mean, this is very important. These indicators of hydrological alteration are very important, especially when it comes to your biodiversity, because fish take cues. And I mean, obviously I'm talking to a whole bunch of specialists in this field, but, you know, obviously the cues of when fish migrate upstream or breed, or, you know, the kind of range of different hydrological conditions that a fish can thrive in or not. So we're trying to bring in those kinds of indicators so that we can start looking at why did a species fall away? Why haven't we detected them? You know, for example, I'll show you in the live view, but yeah, you can see when species are present and when they aren't, you know, as they move out of the system according to the different conditions. And then this one, sorry, it's just a slide I've stuck in, which I was meant to actually talk about earlier, but we record all the users' preferences. So if you work on multiple computers and you've done various analyses, the database on the server syncs with your local systems server as soon as you log in again. So you can save all your different types of analyses and all your different charts and things. But yeah, so that's that. Okay, and then partners data, just to mention again, we've now got the IUCMA to give us access to all their real-time data. And they've actually got more real-time stations than Department of Water Affairs does now for the Nkomati. So it significantly improves our ability to track compliance, because what they do is the same as what we did in the Olifants, is monitor alongside the Department of Water Affairs, which allows us to reduce the uncertainty associated with an unverified gauge. But as you'll know, hydrology varies significantly in short spaces of time. If you go to zero flow at a station, you can completely decimate your biodiversity in a matter of a day. So it's important that we operate at as low a level as we can. So 6 hours, for example, you know, could mean the world in terms of maintaining certain populations of different fish or macroinvertebrates. So yeah, that's essentially that. Okay, and then distribution, as I said, you can go to our website. So we've got a website, biosmart.award.org.za, but I'll show you that as well. And then whenever we release a version to the public, you'll be able to download it. In the future, not in this version, but the next version, we'll be integrating an automatic update feature, so that when you open up the program, it'll say that there's an update available and you can install it. And then, yeah, just acknowledgements. Are there any questions before I, you know, go through a little walkthrough of the program?
Maybe stop sharing.
Hugo, I'm quite curious. It's something we've sort of chatted about before privately, but I think it might have value just to chat about it generally. Obviously what you've done is linking the drivers with the biodiversity is really new. And I think people have been screaming for this for ages. I know certainly our regional Department of Water Affairs has always said, in comment to FBIS, it would really not be great to be able to see water quality data and flow data. And obviously we have that data available at the moment in DWS. What potential is there, and what would it take for, to expand the sort of the connection between FBIS and inwards, beyond obviously your focal area? Because I think it's probably something that a lot of people might be interested to know. Obviously nothing happens without budget, but I mean, is it feasible, and what off the top of your head would it entail? Thanks.
Yeah, so I mean, it's definitely feasible, and the approach we took was to basically keep the data tables within our system, in line with the general Department of Water Affairs structure. So what is nice about Department of Water Affairs is they've followed a very predictable, it's the same, throughout every single catchment, the structure of the text files that you need to process. And that makes it a lot easier to actually move into a new system. Obviously, if we were to expand to other areas, we would probably need to set up individual smaller servers or upgrade the server that we currently have. But I would think that it's actually going to be probably better to have multiple individual servers for each water, larger water management area. Purely because, I mean, basically we've got the bare minimum in terms of RAM and CPU needed at the moment. But if you are pulling data constantly from multiple places and processing, your server will get kind of logged up. And I don't know how, I think it would be more beneficial to have individual CPUs processing data at the same time on different servers than it is, trying to do it, in a single one, like keeping them separate. But yeah, it wouldn't actually take a huge amount from the database side. However, the manual side of things, so like this is where the processing of statistics for the different hydrological sites. So, taking your verified data, processing the statistics, but also checking for data errors, collating all the images. A lot of that kind of stuff is quite time consuming, but from the APIs fetching data, I mean, that's pretty straightforward.
Can I just add, Helen?
Yeah.
Excuse me. I mean, we've already, I think probably the best way to work on this is by a demand-driven approach. As there's a demand pull, then one responds to that. So, that would, I suppose, be the first thing. The other thing is thinking about it beyond South Africa. And, one of the things I've been thinking about is how one would adapt it to, for example, managing the Great Lakes, or, in that kind of context. And then one would also need to understand the management governance systems there to make it usable and tenable and appropriate. And so obviously expanding it beyond the kind of, let's say, the more directly known context would really need strong partnerships with others. So we're looking at expanding it now. It's being expanded into Nkomati, as you know, and just for people not from South Africa, into another area in the north of South Africa called the Umhlatus. So we're just starting a project with them as well. So we've certainly been thinking about it. Yeah.
Perfect. No, that's great. I mean, obviously, partnerships are key, and I like your idea of sort of within South Africa anyway, demand driven. So if, the stakeholders in the Western Cape, for example, identify this as, something that's going to really make a difference in their lives, then the actions get taken to kind of roll it out. But great. I see, Robert, you had a hand up, but you've put it down. Would you want to ask a question? Nope. Any other questions at this stage? Hugo, you're going to do us a live demo now. Okay. Last chance for questions, or are we going to move on to the live system? Oh, Robert. Okay, do you want to take it away, Robert? just introduce yourself when you first ask the question, so we know your context.
Yeah. Okay, now my microphone was off, so I think now you can. Okay, so I'm Robert from Sokoine University of Agriculture. I'm working with Fiji Basin. So my question is going to Hugo. So when we were presenting the inwards, I have noted that inward can analyze the data based on river variables. For example, water quality, water flow in relation to biodiversity variable. Now, can the software be used to relate the landscape factors, for example, housing, agriculture with biodiversity? Is that possible?
Yeah, thanks for the question, Robert. Interestingly enough, we've actually got a WRC grant, or I don't know, yeah, called a grant, and essentially it will be to integrate human health into inwards, but looking at the spatial data. So we'll be pulling in this what we've got called Stats South Africa, which is the different households as well as their dependence on water, and it will be very much visual kind of models. But then also the quality component. So I assume, you know, it would definitely be able to work in a very similar fashion as to what you're referring to with the landscape kind of influences. And I mean, once again, what's nice is a lot of your, what would you call it, GIS functionality that's associated with your web apps can be brought into it. So the spatial kind of analysis can also be brought into it. But I mean, we would probably pull on Tim's expertise there, since that's their domain. But yeah, I definitely think it is possible.
Okay, thank you. Now, another small one. Is it a free open source software, the inwards, or? Okay.
Yeah, so everything is open source policy. Anyone can download it and use it. The only thing that we request is that, you know, you register, we approve your registration just to track who uses it and what they use it for. And obviously we know that stakeholders in South Africa, obviously, I mean, not stakeholders, what do you call them, consultants, will obviously want to get access to this platform because they need to do these kinds of analyses, especially when it comes to a mining license application. And I don't think we've crossed that road in terms of discussing, you know, what happens if it is for someone else using it for commercial purposes. Because obviously we would want it for biodiversity conservation, but not for people to exploit for their own profit. Like, you know, we would rather some form of service fee actually go back into the conservation space if it is utilized for that purposes. And I know, Helen, you guys are probably facing the same kind of discussions internally with IFBIS, because as soon as it really gets traction, you're going to have all these environmental consultants wanting to jump into utilizing it for putting together their reports, and IFBIS essentially does the report for them, if you know what I mean.
Yeah, that's already happening. Our consultants are definitely the lion's share of registered users. But yeah, it's a discussion. Thanks. Tim, I see your hand. Robert, sorry, does that answer your questions adequately? I think so. Tim?
Hi. Yeah, just maybe for Hugo, maybe for the others who are not from South Africa, you could talk a little bit about like how transferable is the sort of the platform that you've built to another, like somebody wants to put it in Uganda or somewhere else. Like, is it really like sewn in down to the nuts and bolts of the platform to the DWS, you know, quality water feeds, or is it something that you think could be easily adapted to another geography?
So I mean, Tim, that's a great question. You know, to be dead honest, what's taken almost 95% of my time in terms of coding has been actually coding the scripts for the various analyses. So, you know, at the end of the day, if you're pulling hydrology as in a time series, it doesn't matter if it's from, you know, a Ugandan format that just needs a slight bit of processing, those scripts still apply. So, you know, all the indicators of hydrological alteration, like, you know, calculating the min flow, max flow, you know, all those different things are what took a hang of a lot of time. The interface is generally actually quite a straightforward process. but the scripts for the analyses are what take a long time, and those can be applied anywhere. I think, you know, to recreate a database for the for the hydrology, say for example in Uganda, is probably not going to be a huge amount of effort at all. What's nice is that the scripts would come along with it to process that hydrological data, and you know, the formatting and the way in which you interpret it. I mean, all of that is definitely quite applicable everywhere, I would think. The only difference would be obviously incorporating their thresholds and their standards, you know, within the system to determine compliance.
Thanks, Hugo.
Any more questions before we move on to a live demo of Inwards? Not looking like it. Okay, perfect. Thanks, Hugo. Take it away.